Hello guys, welcome back to the channel Mathemagix JEE. In today's video and in the upcoming videos, we are going to solve the problems of the sample paper that was posted in the IIT Kanpur website. For those who are not aware of this sample paper by IIT Kanpur, I will link the website in the description. You can check out that sample paper and give it a try before seeing the solutions. Okay. So this is the first problem of this sample paper. It is saying for t belonging to 0 to half, consider the quadratic equation ptx as t minus t square times x square minus 1 minus t times x plus t square equal to 0. Okay. So this is the quadratic equation given to us. Let alpha t and beta t denote the roots of pt. Okay. So then we have to determine which of the following statements is false. So as this is a single correct type question, single correct answer type question, we can check statements one by one. Okay. So we have to pick always the easiest statements first, because if we somehow find that any easy statement is wrong, then that will be our correct answer. Okay. So let us check the easiest option first, option D. Okay. Because this is nothing but the difference of the roots of this quadratic equation. So we know mod of alpha t minus beta t, this will be nothing but root under d divided by mod of a. What is d? D is the discriminant of this quadratic equation. So what will be the discriminant? We can find this. This will be 1 minus t whole square minus 4 times t square times t minus t square, right? So we can take this 1 minus t common, and 1 minus t minus this will be 4t cube, right? So we can write this as t minus 1 times 4t cube plus t minus 1. This thing can be again factorized. How? This we have to observe. We can see that t equal to half will be a factor of this expression, because 4 by 8 plus half is equal to 1, and 1 minus 1 is again 0. So we can write this as t minus 1 times t minus half, then it will be 4t square, then plus it will be 2t, and then it will be plus 2. So this is the expression for d as a function of t. Now let us check this d option. So it says if t tends to half from the left hand side, then mod of alpha t minus beta t tends to 0. So mod of alpha t minus beta t will tend to 0 if d tends to 0. Okay. So d is the discriminant. So if we check d option here, limit t tending to half minus this d will be equal to 0, because t equal to half itself is a factor of this discriminant. So limit t tending to half minus d will be equal to 0. That means this difference of these roots will also tends to 0. That means option D is correct. Now check the other options. PTX, let's check this one because it seems easier. We already know the condition for distinct roots. For distinct roots of a quadratic equation, we have to have the discriminant not equal to 0. So D not equal to 0. So PTX has distinct roots for all t belonging to 0 to half open. Okay. So let us check this. So if we look into the expression for d as a function of t, we can say as t belongs to this interval 0 to half, this dt is non-zero. Why? Because t minus 1 will not be 0. T equal to half is not there in the range of t, right? So this factor will be non-zero, and also this factor, if we carefully notice, this factor is always positive, because 2t square plus t plus 1, this quadratic is always positive. So this does not have any real factors. So we can say this discriminant is non-zero for A option. We can say D is non-zero for t belonging to 0 to half, right? So Px has distinct roots for t belonging to 0 to half. That means option A is also true. Now we have to check the other two options. either one of them is our correct answer, which is the false statement. Okay, so now let us check the B option. For infinitely many values of t, the corresponding root alpha t is rational, and for infinitely many values of t, alpha t is irrational. Now, what is the condition for rational and irrational roots? Right? So we recall that rational root means that d is perfect square. So if d is a perfect square, we can clearly imagine that the radical sign will be omitted from the overall expression. Okay, because we take the square root of the d, which is the discriminant, and then we find the roots. So if the square root sign is omitted or the radical sign is omitted, then there will be no irrational terms left in the final expression. Okay, so we can say we have to check the nature of this discriminant. So if we check this d as a function of t here, so we can use the wavy curve method. So these are the points t equal to half and t equal to 1, right? These are the points where d becomes 0, because we already found an expression for d. Now see, here will be plus, this will be minus, this will be plus, and from 0 to half this d is positive. Okay, so we can say that d of 0, if we find, let's say d of 0, if we try to find, d of 0 is basically 1, and d of, let's say we find d equal at t equal to half. So at t equal to half, d will be equal to 0. As from 0 to half this d is positive, that means this at t equal to 0 it is 1, at t equal to half it is 0. That means we can say clearly it should cross each and every point in between this 0 and 1, right? Because d of t is a polynomial in t, and we know polynomials are always continuous functions. So if there is a point f of alpha and there is a point f of beta, then from alpha to beta, if f is a continuous function, fx should cross all the in-between points. This is the result of the intermediate value theorem. So we can say this d will take all values from 0 to 1, right? Now, in between 0 to 1, there are how many perfect squares? Yes, you are right. There are infinite numbers of perfect squares. How? Let's say we take the form 1 by n square. Okay. So 1 by n square for n equal to 2, 3, 4, so on up to infinity. We can take any number, any natural number n greater than equal to 2, and we will get a number between 0 and 1. And at that point, d will be a perfect square. So overall, the radical sign will be omitted. That means there are infinitely many values of t for which the corresponding root alpha t is rational, and for infinitely many values of t, alpha t is irrational. That means this B statement is also true. That means by method of elimination, C option must be incorrect. Okay. And for C option, we can prove this statement is false by taking appropriate counter example. Now, what will be that counter example? This I am leaving as an exercise for you. Don't forget to leave a comment in the comment section about this counter example. Okay.